Hi, welcome to lesson number 8 on this tutorial series on practical electronic designs. In my previous lecture, I introduced us to a concept known as voltage division, and that concept will be used to design a light control system today. And today I'm introducing us to a simple light control switch design. So let's get started. To design this system, you will be making use of a component I've not told us about before now, and that's a light dependent resistor. A light dependent resistor is a resistor in itself, just like this, but its resistor value, its resistance value rather, changes due to the amount of light falling on it. So if light falls on it, its resistor value changes. So a light dependent resistor or photoresistor is an electronic component that is sensitive to light. It's sensitive to light, the change in light, the brightness of light, the dimness of light affect the resistance value. So the resistance changes when light falls upon it. It should be noted that the resistance is inversely proportional to the brightness. So the resistance of this resistor is inversely proportional to the brightness of the light it detects. What this is saying is that whenever light falls on it, as the brightness of the light increases, the resistance of this resistor decreases. So that's why I said it is inversely proportional. So once the intensity of light increases, the resistance of the light dependent resistor reduces, because when there is no light on this sensor or this device or this resistor, the resistance value is very high. So when everywhere is dark, the resistance value is very high, about 1,000,000 ohms. That's 1 mega ohm, very high. So as light begins to fall on it, the resistance value begins to reduce to some hundreds ohms, and that is the way the light dependent resistor works. So this is the circuit, light controlled circuit. This circuit is to control the turning on or the turning off of this LED, of this light, this LED here, and we'll be switching it on and off with the use of this NPN transistor. You can check my previous video, lecture number 6. I've explained how a transistor works. This is the LDR. Whenever light falls on it, the resistance value changes, and that affects the switching of this system. Now you should understand that in my previous lecture I explained voltage division, where we had resistor R1. That's lecture number 7. You can check it out to understand this concept. I explained voltage division, and I told you that we had resistor number 1 and resistor 2, and if you want to get a voltage in between the series connection, there's a formula to do that. I gave us the formula in that video. So whenever two resistors are connected this way, there will be a voltage drop here, and that voltage drop will be used to switch on this transistor and in turn switch on this LED. So when there is no light on the LED, let's assume there's no light falling on the surface of the LED, the resistance of the LED at that point is very high, about 1,000,000 ohms. That's very high, 1 mega ohms, very high. And because the current flowing from the 9-volt battery is not able to flow through, because this high resistance will oppose the flow of current, the current flowing from a 9-volt battery cannot overcome this. So at this point we are going to be getting about 0 volts, and 0 volt cannot turn on the base of a transistor, and so the transistor remains off, because the base of transistor is not turned on. There's no current flowing through into the base, and there's no voltage up to 0.7 across the base and the emitter of the transistor. I've explained I've explained all this in lecture number 6. You can check lecture number 6. You understand what I'm talking about here. So because there's no voltage here and there's no current flowing through the base into the base, the transistor remains off, and since the transistor is off, current will never flow to turn on the LED. Remember, current only flows through a closed loop. So when there's an open circuit, current will never flow, so this LED will remain off. So if the intensity of light begins to increase, let's say light begins to fall upon the LDR and the intensity begins to increase, I told you before that the resistance value begins to reduce, and as the resistance value begins to reduce to some 100 ohms, about 100 ohms or 500 ohms or whatever, then a voltage division network is formed between this LDR and this 10 kilo ohms resistor. And so because of this, there will be a voltage here at this point greater than 0.7. When a voltage greater than 0.7 is seen across the base and the emitter of a transistor, it allows current to flow into the base, and when current flows, the switch closes. So when there is light, when light begins to fall on the LDR, what happens is that the resistance value begins to drop, and the current, though there may be an opposition to the flow of current, but more current will flow through because it cannot oppose all the current flowing through. And once it crosses this point, there will be a voltage drop, and at this point we'll get some voltage above 0.7 volts, and that will allow current to flow through this 1 kilo ohm resistor to the base of the transistor, and in turn it closes the transistor. I'm using a switch here to represent a transistor. Remember I said a transistor is just like a switch, an electronic switch, and so this LED comes on, and that's just all about the circuit. Very simple circuit. So thank you for watching this video. Like, subscribe to this channel. In the next video, I'm going to build this circuit. I'm going to build it on the breadboard. So until then, stay safe. Thank you.